Good morning, good afternoon, and good evening to wherever you are on the ball we all inhabit. My name is Andrew Glaser, and today I would like to teach you how to find the x-intercepts of the following function. And this function is kind of a little special because it has the highest power of the fourth. All right, so it might be a little tricky, but it's really not bad. I'm going to try to show you something that might look familiar. So let's pretend we have a function here. All right, I'm going to draw a little graph. And the first thing is we kind of have to understand, well, what the heck in the world are x-intercepts, right? X-intercepts are just going to be the values of x. You can also think about them as the coordinates, all right, of those points where the function crosses the x-axis. Okay, remember the x-axis is usually the horizontal, and the y, or the function of x, is usually the vertical. Now, it turns out that there's something you know about each of these points, all right? It turns out that those points have something in common. Do you know what they are? Or do you know what it is? Well, it turns out that you don't know, okay, the x value, but you do know the y value, right? So in other words, you know that the y value for each, or the function's value, better be 0 for both, right? That you know for certain because it lies on the x-axis. That's true about all points along the x-axis. The y value, or the function's value, will be 0. Now, if you're trying to find x-intercepts and you come to that conclusion and you realize that principle, you're on your way. Okay, so in other words, I'm going to write it down that y, which is the same thing as saying f of x here, has to be equal to 0. So when you're finding your x-intercepts, what you're trying to do is you're trying to find the x values of the function that cause the function to become 0. So let's plug in 0 for f of x now. So now it's going to be 2x to the fourth plus now 6x squared minus 8. Okay, so before you start doing some math, you want to think to yourself, can I find maybe some values of x that will cause this thing to become 0? So you just think about it. You start making a guess. If x is 0, well, these two terms go to 0, but then the right-hand side, is going to be negative 8, and negative 8 does not equal 0, so that's not going to work, right? And then you might start to guess. You might say maybe 1. Will 1 work? And, the way these problems are made, it might, right? If you plug in 1 for x here, this whole thing is 2. If you plug in 1 for x there, this whole thing is 6. 2 plus 6 is 8, and 8 minus 8 is going to be 0. So, oh, wait a minute. Wow, lucky us, right? Lucky us. So that works out, okay? So we actually know a value, x is equal to 1, and you're like, oh boy, are we gonna guess and check every value here? No, we're not. But I want you to see that that's kind of the intuition at the beginning. You can kind of, what we're trying to do is we're trying to search for x values that produce a 0 value on the right-hand side, okay? Because 0, to make this a true math statement, 0 has to equal 0, all right? Now, obviously, this is not going to be the most efficient way to do it, but that's the goal. We got to find those x values, okay? Now, we can sit here all day and guess and check, right? All of a sudden, you say, well, what happens, Andrew, if you change that to a 7, negative 7 now instead of negative 8, would your method work? It wouldn't work as well, right? You'd be sitting here guessing for quite a while, all right? But I don't suggest you guess anyway, okay? But I want you to get a little bit of intuition first. Now, after you're like, okay, I'm done with that, teach me now. Teach me the method. Well, first I want to teach you how to think, and then we'll go to the method. Now, the method here, and which I will proceed to now anyway. So the method now is you want to try to identify how to factor this, okay? You have to try to figure out, what can I do to this thing to get it into some factors? And then maybe we can start solving for the x-intercepts. And now the thing is, it's always like, okay, yeah, I learned about that. I know I got to factor it. I don't know why. Well, let me show you why. So what I realize is that I have a common term of 2 in each. So I'm just going to pull that term out, okay? Let me pull the 2 out. So this would just be x to the fourth then, plus 3x squared minus 4, okay? Now, the idea here is that if I could just get this whole term to go to 0, right? If I could somehow figure out the x values in which make this 0, then 0 times 2 would equal 0, right? So I already factored something out, and I realized that I can just set this thing now equal to 0 because of the reasons I just mentioned, that if this thing becomes 0, then the whole value, 0 times 2 is obviously going to be 0, right? So now you can kind of break this down a little more. You can say, okay, well, I can kind of get rid of this function. I'm trying to find those x-intercepts, and now I'm just going to set this thing equal to 0. 3x squared minus 4 has to equal 0. Okay, now you're like, well, great. Where do I go from here? Watch. If I change this now, and this is the beautiful part, okay, if I change this from a 4 and a 2 to a 2 and a 1, which I won't write the 1. I'll just leave it there. Can you solve this quadratic for me? Remember, you need two values that multiply to be -4 and that add to +3. What would those values be? I think I heard you. I think I heard you say it's going to be a +4 and a -3. What? 1. Huh, gotcha, right? It's going to be -1, okay? So, all you then do, right, and you're like, oh yeah, I remember, I just plug in the x's here, right, and this is now my binomial. And that's how I would have solved the quadratic, okay? And then we could have went about our business from there. Now the thing is, what you have, and let me just delete some of this stuff, and you'll see now the similarities, okay? You don't have, though, x squared here, and what happened to part of that number 4? There it is. You don't have x squared here. Technically, you don't have x to the first. What you do have is you have x to the 4th, and you have an x squared here. But what I'm trying to have you notice is I want you to change now one thing in this binomial and only change one thing in that. And you can, by changing, I mean you can add something, okay? I don't mean physically add, like add a +2 or something like that. I mean just place something in there. Place something in either one of these two that will then work and make, when you foiled this x times x times 1, blah, 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 blah. When you foiled it, it would become this function. Do you know what it is? What would you have to change? Well, if you said just make that an x squared and that an x squared, you would be correct, my friend. That's all you have to do. Okay, that's all you have to do. Now, if you go, right, and you x squared times x squared is x to the 4th. X squared times minus x is going to be -x squared, right? +4 times x squared is going to be a +4x squared. When you combine those terms, that's going to be a +3x squared. Oh my goodness, there it is. And then +4 times -1 is going to be a -4, right? You see it? It all worked out. Okay, it all worked out. Now, where do we go from here? Well, the reason why we factor is this. I know that this whole thing, this whole term will become 0 if I can do one of two things, just like I was thinking over here. These two terms are multiplied, so as long as one of them is 0 at one point in time for a certain value of x, then I know this whole side's going to go to 0 because 0 times anything, I could care less what that is, it's going to be 0, right? So what I want to do now is I actually want to set both of these equal to 0. Okay, both of these equal to 0. So now here we go. So it's going to be x squared plus 4 equals 0. And then I'm going to have x squared minus 1 equaling 0. Cool? Now, how do we solve this? So we solve this now, but we could do a little math. I mean, we could do this a whole bunch of ways. Now, you might notice this. You're like, wait a minute, that doesn't look, shouldn't it be a -4 in there? That would be a perfect square, and you'd be right. What happens here is that this turns out to be like some imaginary roots on in here. Okay, there's some imaginary roots. Watch. Go to your calculator. Oh, by the way, take a look at the link in the description below. I'm going to leave you a link to find to watch a video. Literally, it's like 3 or 4 minutes. How to program this quadratic function in your calculator. You're absolutely going to love it. So when we look at this function, the a value is 1. There is no b value in there, right? And the c value is going to be 4. You know that, right? The a x squared plus bx plus c kind of deal. So for this function over here, it's going to be a is 1, b is 0, c is going to be +4. Hit enter. Ooh, we get eyes, right? We got eyes. Well, of course you have eyes. I mean, we got eyes here, right? We got imaginary numbers. No good. We're not dealing with imaginary numbers here, okay? We're not dealing with imaginary numbers. So what that means is I can kind of just say that this whole side is just a bunch of garbage, more or less, okay? Now let me show you the math way to do it algebraically, right? If you minus 4 from both sides, what you would have come up with that is then you would have come up with x squared is equal to -4. To solve this, then you would have had to take the square root, and you cannot square root a negative number. Okay, you can't do it. It would have been x is equal to, what? Can't be done. You can't do it at least without imaginary numbers. Okay, and we're not talking about imaginary roots here. So this is just does not exist. I'm just going to write DNE. Doesn't exist. Okay, can't do it. Over here now, I want real numbers, by the way, not imaginary numbers. So over here, what can I do? Now you can do the same thing. You can clear this on out. You can hit the program again, run the program. Okay, run the quad program. And then your A value is going to be 1, so type it in. The B value is going to hit enter. 0 is the B, and then your your C value is now -1. Hit enter. Ooh, right? I get both x plus 1 and x minus 1. Now look, we already said x should be equal to 1. If x is equal to 1, then y would be 0, and this is an x-intercept, and that's basically what the calculator is telling us, right? That's where some nice little intuition comes in handy. But now let's say you want to know the algebra way because you're like, well, that's great, Andrew. I might understand all that stuff, but when I get to the test, my teacher's going to want me to write out some work, and I can't just say, well, I thought about it. They're going to be like, oh, you cheated, right? I'd rather have somebody who thinks about it rather than somebody who can just write down a whole set of procedures, but that's me. Anyway, what you're going to do here in order to solve this is you're going to take the square root of both sides. Okay? Square root of both sides. When you square root x squared, that's just x. When you square root 1, well, square root of 1 is just 1, but you have to consider that when you square root a value, the number could have been positive or negative. Okay? There's some actual debate about this, whether it should be, I don't know. All I know is that it will work. It works for this. Okay? So keep in mind when you do square root, you get a positive and negative answer. All right. Now, which means you have two answers. You have x plus 1, and then it should also be x minus 1. Okay? These are going to be the two x values. That's these question marks right now. Okay? That's the question marks for this particular function. Okay? Now, let's see if this does hold true. Okay? Now, if you're like, all right, I understand the method, we got the answers, but I still don't get it. X equals 1, how is that the x? How is that the value of x? Well, let's look at the graph. Ready? Go to the graph, hit 2x raised to the 4th. Hit over, plus now 6x squared. And then minus 8. Okay, make sure it's correct. And then go to zoom. I'm going to go to 6 for standard. Look at that, right? Let's zoom in a little bit. Go zoom, hit 2, enter. Wow, right? Each one of these tick marks now represents a value here. Each represents a value of 1. So if I count to the left 1 unit, it looks like there's a tick mark right there. That's -1. That point right here, ladies and gentlemen, is -1, 0. That's what we were saying, right? There's the value. Same thing over here. Count 1 over from the right, from the origin, and that's going to be +1. Okay? That's it. I mean, there's the picture of it. There it is, right? If you're still not convinced, you can go to the table in your calculator. Hit second table. I got it incremented by half. I hate that. Let me just hit the plus button. I can now change the increment. I only want to increment it by 1, okay? And I'm going to hit enter. All right, that looks a little better. In any case, when I pull this on out, when you look at your table, you have to remember this, that the x-intercepts are going to be the values of x when y is equal to 0. So those x values are going to be -1 and 1. +1 and -1. And that's it. All right, that's all it is. It's kind of nice. It's kind of beautiful, right? In a weird, strange way. But beauty, remember, is in the eye of the beholder. So guys, thank you very much for tuning in. I really do appreciate it. I do hope this video helps. And if it does, if you don't mind, give us a hand. Like, subscribe, hit those buttons. And if you don't mind, maybe tell some of your friends or classmates. All right, we would love to help more people. And if we're able to help you, maybe we're able to help other people as well. It would be awesome if you could do that. Also, check out our channel because we don't only have math here. We got physics, chemistry, and we got a lot of other stuff coming out soon. I look forward to helping you with more problems. Take care.